Now let's see with a practical example how all of this works. I'm using the same demonstration dataset as in the introduction tutorial, which consists of a few exposures from the wide-field imager at the Isaac Newton telescope in La Palma, Spain. This camera is 4 CCDs. It's called the wide-field imager at the INT. And as you can see here, we have 5 biases, 5 flat fields, and 4 science exposures. Now, before I start the processing, have a look at the CPU bar and also the memory bar. As you can see, the memory bar shows that I'm already using about 11 gigabytes of memory, even though not many processes are running on my machine currently. This is just a feature of Linux that keeps a lot of data in cache, so it's not actively used. So let's start this HDU reformatting, and I'm also creating the master bias and the master flat field. And then let's start. So you see the CPU bar goes up to about 600%. So 6 CPUs are being used, and the memory bar is slowly increasing. So it'll take a little longer to finish. Now we're splitting the science images. And then the master bias and the master flat field are being created. Okay, this is done. So now when we look into the science directory here, we see that we have a total of 12 exposures. Initially we started with 4, but as I told you, each exposure of this instrument has 4 detectors, which you can recognize with the number 1, 2, 3, and 4 here. And there's also the character P inserted into the file name. That means this HDU reformatting step has been done. That simply means pre-processing. That includes gain correction and overscan correction. Now let's look at the memory viewer in THELI. You can access this by clicking on this tab down here. And there you can see what is going on internally. Now we can see that we have all the files of the current processing stage on drive as FITS files, which you can also see in the console here. But they're not in memory. So the level 0, the current data, is not in memory. This is for technical reasons, which I won't explain further. And then let's apply the biases and the flat fields by clicking on this step here. And then let's see what happens in the memory viewer. You can see the images, they got loaded into memory, and then they got pushed down into the first backup level, the L1. So the level L0 contains now the debiased and flat fielded images, but they're no longer on drive. As you can also verify here in the console, you see this directory is now empty apart from 2 subdirectories which contain the raw data and these pre-processed images. But the current state, the debiased and flat fielded data, they are not on disk, they're only kept in memory. So let's add another step, collapse correction. This is used to remove horizontal or vertical gradients in the images. And if we do that, you will see that the data that is currently in level 1 will get pushed down to level 2, and level 0 will get pushed into level 1. So let's run this. And again, we do not have FITS data on the drive. At this point, you probably want to know how the images look like that you have processed. Since you do not have a FITS file that you can inspect, you can directly look at the data as they are kept in memory. And to this end, you simply click on one of the columns in this matrix here. So for example, say you want to look at the data, how it looked like after the gain correction, the overscan correction were applied. You just click here, and then you get the image browser. Let me rearrange the windows a little bit. And if you want to see how the image looks like after the flat field and the bias have been applied, you simply click on the second column here, and then you can blink between the two and see that this correction was actually successful. You can also look at the collapse correction, which is removing a slight vertical or horizontal gradients. You can probably see this changing the brightness level a little bit. You can also cycle between images by selecting them. So this is a very easy way of eyeballing the data. If at this point you want a copy of your image on disk, real fits file, say from this image, you can simply click this checkbox here, and then this image has been dumped onto the drive. If you want all of the exposures, you can achieve this by clicking on the button up here. And then you created fits files for everything that has been kept in memory so far. If you're unhappy with the current result, you can restore an old status. For example, the previous one that has been called PA, when that was before the collapse correction, so the second column here. To this end, you can select PA images here and then click on the restore. And you see the collapse corrected images have disappeared from memory, and this PA status is now the current status. What I would like to show you next is how to deactivate a certain exposure. For example, if the seeing was particularly bad or if the tracking failed. To this end, I created fits files for all the exposures, so you can also see not only what is happening in memory, but also what is happening on the drive. And now let's say that this exposure down here is bad. If you don't want to use it anymore, you simply deactivate it by clicking this button. Then software tells you that this exposure has been deactivated, meaning it will no longer be used. On your drive, what will happen is you get this inactive subdirectory, and you have a look in there, you find the exposure in there. If you change your mind, you can activate the exposure again, and then this fits file is restored to its original place. Now, let's say I deactivate this, and then we continue processing, doing this collapse correction. And you see this image remains deactivated. And now if you want to restore it, THELI does not let you do this, because at this point you get a mixture of different processing stages, and this is inconsistent, and therefore you cannot do this. What you can do, however, is you can undo this last collapse correction simply by restoring the second column here, PA images, restore, and then you can activate this exposure again. Lastly, I want to show you what happens when you exit the program and you still have unsaved images in memory. So let's do this collapse correction again. And as you can see, now this latest processing status is not reflected in fits files on the memory. And when I click the close button up here, then THELI warns you that unsaved images have been detected. And you can choose to save all these latest images, or to save everything that is currently kept in memory. That includes calibration files and so on, or to just close without saving. So let's save with the latest images and close. Thank you for watching. I hope this tutorial will be useful for your work.